So if you're confused by all the nomenclature, ic, us, ate, ite endings and all of that stuff, let's see if we can unpack that by considering the element sulfur and materials made from sulfur. Firstly, S represents the element sulfur. Now we know that sulfur can gain 2 electrons and it becomes an ion. When it does that, that material is called sulfide. So the "ide" ending represents an element that has gained some electrons. Now we also know there's a very common acid that has sulfur in it, and that's sulfuric acid, H2SO4, battery acid. And what do acids do for a living? They give up hydrogens, they give up protons. So if we take the 2 hydrogens away, we get a -2 charge. And when an ic acid does that, the resulting anion is given the suffix -ate. We also know that ic acids, some of them have a family member that has 1 less oxygen. Any acid that has 1 less oxygen than the ic acid is given the ending -us. In this case, H2SO3 is sulfurous acid, but it's still an acid. And what do acids do for a living? They give up hydrogens. And when sulfuric acid gives up 2 hydrogens, it takes on a -2 charge. And any us acid and the anion resulting from any us acid is given the ending -ite. And finally, we have the material SO3. It's not an acid. All it is a binary compound. So the SO3 should not be confused with H2SO3. Or this SO3 without a charge should not be confused with SO3 with a -2 charge. The SO3 with a -2 charge is an ion sulfite. The way that you tell these 2 apart is noting one of them carries a charge and the other one does not. So, charge-neutral SO3 molecule is a simple binary compound named sulfur trioxide. So some of this is memory, sulfuric acid. Some of it you figure out from using the families. Some of it you recognize as being a charge-neutral species. And some of it you figure out by determining how many electrons an element might gain when it becomes an anion. So remember, elements go to ide, ic acids go to ate, and us acids go to ite.